Hi everyone, my name is Michael. I'm the Technical Director at Resonate Systems and also one of the co-founders of Resonate Systems. I've personally been using LabVIEW for the past 15 years and Resonate Systems has been an NI Alliance partner for the 8 years since it started. Who are we at Resonate Systems? We have an amazing team of 13 people built up mainly of engineers. We've got mechanical, mechatronic, computer systems, our management team, and a physicist who also happens to be pretty good at LabVIEW. What do we do at Resonate Systems? In its simplest form, our goal is to do interesting and challenging work for customers and partners who we care about and whom we share common goals. And typically in the test and measurement space. Our roots are in multi-channel data acquisition systems and signal processing, predominantly the type used in predictive maintenance and online condition monitoring systems. We then moved into more custom system development and systems integration, filling that gap where customers can't quite find that off-the-shelf solution to meet their needs, and we're able to develop something bespoke that can. This in particular is where LabVIEW and the NI platform worked really well for us. For example, we could take a compact Rio platform, select some C-series modules that suited the sensors we needed, whether it's accelerometers, strain, or temperature, and then use LabVIEW to customize that application, whether it was for control, acquisition, or more signal processing. The following slides show some example projects in online condition monitoring and custom system development. So this was probably one of our largest projects. It was a Insight CM deployment for SA Water, which is the water utility in South Australia. So it was deployed across 130 pumps spread across 30 pump stations. So at the time, it was NI Insight CM Enterprise Condition Monitoring, which then migrated across to Cutsforth, but the hardware is still NI. So it's compact Rio systems with NI C-series modules, so predominantly acquiring from accelerometers, prox probes for displacement, and also temperature. Software on the compact Rios was Insight CM SDK, which then allowed us, because it was open, allowed us to add some customization based on what SA Water needed. So that was adding in Modbus TCP/IP capability, some alarming, but also digital I/O straight to PLCs. So you've got some stats there as well in terms of how many brackets. We've got a mechanical design fabrication team. So a lot of the custom brackets for mounting the prox probes, because a lot of these pumps are, probably 100+ years old. You had to design custom brackets to make sure your prox probes were lined up where they needed to be. This slide just shows some of our custom measurement systems. So just going around the pictures, you've got radar, structural verification. We've got distributed wind speed monitoring. I think in the middle there, we had a PXI temperature and speed control setup, and then also a few rail applications. So the top right one there is bogey strain gauge monitoring, and then the track condition one is actually it's an update to a VHDL code, which was using, I think, FPGA for triggering of image capture for a wayside condition monitoring system. So that was developed by somebody else, but we came in to help them refresh the FPGA component. These are all typically defense applications, but also a few in the sort of rail transport region. We also use LabVIEW to develop applications and user interfaces for production test systems. So a couple examples here are, so the one on the left is for a company called MicroX in South Australia. So they develop quite an innovative micro X-ray system with applications in medical and defense. So the example there is they've got multiple production test stations where they go through different stages, whether it's bake out and X-ray conditioning, etc. So the last one here, that example is an end-of-line system where they go through all of the final checks, ideally get a set of green lights and then move on from there. So we were involved there predominantly. They had engineering, applications developed internally, but they were very much a mix of an application that was developed for engineering testing and then used for production. So a lot of it was really, can we have an interface that's designed for our production engineers where it's actually easy to see, they've got the information right in front of them. We've also done a fair bit of work with universities. One example there is a active noise control system using that least FXLMS algorithm. A lot of that was actually the heavy lifting was done within FPGA with a UI done on a host VI. We use LabVIEW and TestStand to create automated test systems. Again, a lot of it is for universities and also defense. A couple examples there. So I think Adelaide University had a grant to use OPO lasers to fire into particular materials and then use spectrometers to pick up the response. So most of that was for material identification. So where we came in was to help them actually automate. So prior to that, they were doing, I think they had a student actually go there and just collect results, probably take 2 weeks to collect it and then start analyzing it. So a lot of it was using TestStand to automate that. So LabVIEW was the interface to each of the 5 or 6 different instruments, and then TestStand to sequence all of that. So they can effectively set it, run it for however many days, and then start processing results. So again, we find the work with universities is enabling them or facilitating them to actually get the results, which is what they've got that money for in that case, rather than burn all of that time developing the system and no time to look at it. For DST, so the Defence Science Technology in Edinburgh and Adelaide, that was a automated test system. Again, that was for RF test validation. We also developed a flexible data acquisition system, what we call DataFlex. So sort of an in-house product that we both sell and rent out. So it's based on the Compact Rio platform, and it's sort of deployed on construction sites, laboratories, trains, radars, etc. The DataFlex ecosystem sort of also has a cloud platform on AWS that then handles databasing, alerts, and further post-processing in Python. Outside the LabVIEW development team, we also develop in Python. We do a little bit of VHDL, though typically it's just enough to convert it to LabVIEW FPGA. But we also have mechanical design, fabrication, and electrical design. We also are distributors for a few different companies overseas, with the key ones being, you've got here, Ava Monitoring ground vibration loggers for a company in Sweden, and EMF cancellation from a company called Spicer over in the UK. Couple here as well is data physics or MVT from US and UK, where they're predominantly shaker systems and shock test systems. So an example of the top left one is a water-cooled shaker that can produce 80 kilonewtons to 220 kilonewtons. So probably about, a couple meters in size. Sort of in closing, the decision to sponsor this GDevCon event was an easy one, both for me personally and also our company, as we saw it as a great opportunity to help reverse or alter the trend of the past few years, and preferably in the right direction. While you've seen in previous slides that we do some projects outside of LabVIEW and NI, our largest projects to date and a significant part of our code base, libraries, and expertise remain within the LabVIEW and NI sphere. So it's very heartening to see the enthusiasm in this room. And I'd like to thank everybody here, the attendees, presenters, organizers, and sponsors for taking the time out of your busy schedules to be here. We very much hope that you found it worthwhile. Thank you.